Hello everyone. Today our lecture is about atomic number and mass number. So as we have discussed about atomic structure, that how the electrons and protons they are present inside the atom. So today we will study that what is atomic number. I told you earlier that atomic number is the number of, it can be defined as the number of electron or number of proton. Okay, most specifically it can be defined as the number of proton. Number of proton is called atomic number. Why we use number of proton? Because we know that number of electron and proton are always equal. Number of proton and electron is always equal in any atom, but we know that during chemical reaction electron they take part during any chemical reaction, okay, either through transfer or either through sharing. But proton, they do not take part in any chemical reaction, and they are present inside the nucleus. So that's why their number does not change. Okay, because the number of proton does not change, so we will consider the atomic number as number of proton. Okay, most of the time. And electron is take part in any chemical reaction, so we will somehow we will neglect it. But still, we should conclude. You must understand that number of proton and electron in any neutral atom, it is number of proton and electron is equal. Is that clear? And it is denoted by the symbol Z. Okay, Z is given to the number of atomic number. Okay, so number of proton is called atomic number and its number is Z. Is that clear? On the other hand, mass number can be defined as the collective number. Collective number of proton and neutron present inside nucleus is called mass number. Mass number is the collective number of proton and neutron, and its symbol is A. Okay, symbol is A, and the formula for calculating number of electron and proton, formula is A is equal to proton number plus neutron, and stands for neutron. Okay, formula is A is equal to Z plus and neutron. Is that clear? So in the same way, from this formula, very important formula, okay, from this we can also deduce, we can also find the number of proton or atomic number. So atomic number is equal to mass number minus neutron. This is one equation, this is second formula for finding the number of atomic number. If we know the mass number and neutron number, we can find easily the number of proton or atomic number by deducting the amount of neutron through mass number. Is that clear? So this is how atomic number and mass number. So if neutron number is, you can also find number of neutron from this first principal formula, that is number of neutron would be equal to mass number minus atomic number. So this is third type of formula. So from this formula you can find both mass number, atomic number and neutron, just plus minus, you need to do this. Okay, so let's do some examples related to the mass number and atomic number. For example, there is a given amount of carbon. Okay, carbon, its atomic number is 12, and its mass number is 12 and atomic number is 6. So what is its neutron number? So we can easily find that, we know that n, is equal to A minus Z. Neutron number would be 12 minus 6, 6 or the neutron number. Okay, so let's do another example. For example, sodium. Okay, sodium mass number is 23. Mass number is 23, and this mass number is 23, and proton is, sorry, atomic number is 11. So neutron would be 23 minus 11. It comes out to be 12. So there are 12 neutrons in sodium. Is that clear? The same way you can easily find the atomic number and mass number. For example, let's suppose iron. Okay, so here we do not know mass number, and atomic number is given, that is 26, and neutron number is also given, which is equal to 30. Okay, so we know that mass number is equal to atomic number plus neutron number. So definitely we will add 26 plus 30, and it comes out to be 56. 56 is the mass number. Okay, so it means that there are 56 particles, subatomic particles inside the nucleus. Okay, and they have 26 electrons and 26 protons, 30 neutrons. Okay, in the same way, for example, let's suppose strontium. Okay, strontium, here here mass number is 88, and atomic number, neutron number is 50, and we do not know the atomic number. So definitely we know that A is equal to atomic number plus neutron number, and Z will comes out to be mass number minus neutron number. So here 88 minus 50, atomic number of strontium would be almost 38. Okay, so 38 is the proton number, or it is the electron number, or simply we can conclude that is the atomic number. Okay, now very important question, very important part of the lecture as well. Keep listening carefully, that how to find the electron number in ions. Okay, if ions are given for us, how we can find their electron number? Let's suppose we have sodium. Okay, we know that sodium, most of the time sodium, suppose that this atomic number of sodium is 11 and mass number is 23. Okay, usually when we are writing the atomic number, it is written on the top left and mass number on the top bottom. So and its charge is +1. Okay, what does it mean? It means that sodium lacks 1 electron. Sodium has given 1 electron. Okay, or it has loses 1 electron. As a result, proton number is increased by 1. So that's why the charge, positive charge, is +1, means the positive charge inside sodium is increased by 1 because sodium has given 1 electron. Okay, so what will happen, that its charge is +1. +1 charge means that that respective element, that respective atom has given 1 electron. And if suppose this fluorine, okay, its charge is -1, it means that it has gained 1 electron. So proton number is decreased by 1 charge. Okay, if we compare this number of electron and proton, it means that proton is lesser in amount and electron is increased by 1. So that's why the number or the amount of negative charge inside the fluorine atom is increased by -1. In this that's why. Okay, so this is how you can understand the positive charge. Positive charge means that that respective atom has given 1 electron, and negative charge means that that atom or that element, that atom has gained 1 electron. So negative charge is increased by 1 as compared to the number of proton. Okay, so here in the sodium, how can I find number of electron? Number of protons, as I told you, it will remain as it is. It will not change. Okay, the number that is being changed is the number of electron. Okay, so we will calculate that. We know that number of proton here, mass number is 23. Okay, and it is present inside the nucleus. Okay, and then proton number or atomic number is 11. So electron number, it is being decreased by 1. So 11 minus 1 is equal to 10 electrons. So this sodium plus 1 charge, sodium ion having a charge of plus 1, it have 10 electrons. Is that clear? In the same case, for example, magnesium having atomic number 12 and mass number of magnesium is 24. Okay, its charge is plus 2. It means that this magnesium atom has lost 2 electrons. Okay, so I will atomic number which is given, that is 12. Okay, and so how do I find number of electrons? So electron number would be equal to 12 minus 2. It will become 10 electrons. Is that clear? In the same case, aluminium atomic number is 13 and mass number is 24. So here and atomic number is 13 and its charge is plus 3. It means that this atom, aluminium, has given 3 electrons. So a number of electron is equal to 13 minus 3, 10 electrons. Is that clear? So for example, iron. Okay, iron atomic number is 26 and mass number is 56. Is that clear? So atomic number is 26, atomic number. So from this atomic number we will deduct 3 and its electron would be 23. So overall 3 electrons are present in ion of iron. Okay, if for example Fe plus 2, then what will we do? Fe plus 2 charge, 26 is the atomic number and 56 is the mass number. So 26 minus 22, it comes out to be 24 electrons. What if there are negative ions? For example, oxygen, oxide ion, minus 2. Okay, atomic number is 8 and mass number is 16. Okay, so here atomic number is 8. So minus 2 here, it means that this oxygen has gained 2 electrons. Okay, as a result, number of negative charge is increased by 2 as compared to proton. So its atomic number is 8. So what will we do? We will add plus 2, 10 electrons logically. Okay, so this oxide ion have now 10 electrons but 8 protons. Is that clear? In the same case, for example, fluorine minus 1, atomic number is 9 and mass number is almost okay. So here atomic number is 9. Okay, we are not going to do it with mass number. So Zite is 9 plus 1, 10 electrons. Is that clear? So this is how we can also find for this fluorine. For example, nitrogen. Okay, mass number is 14 and atomic number is 7. Okay, so minus 3 charge. What does it mean? It means that we will add this 3 electron because nitrogen has gained 3 electrons. So 7 minus 3 is equal to, plus 3 is equal to 10 electrons. This same case, for example, sulfur, mass number is 32, atomic number is 16. Okay, if for example it have minus 2 charge, what does it mean? It means that they have gained 2 electrons. So atomic number is plus, here electron is going to plus charge number. Okay, so this 16 plus 2 will be equal to 18 electrons, 18 electrons and 16 protons. Okay, so for example, sulfur charge now, for example, plus 4. Okay, if charge of sulfur is plus 4, so what does it mean? It means that it has lost 4 electrons. So what will we do? We will deduct 4 electrons from its atomic number. So here it will become 12 electrons. Okay. In the same case, for example, charge of sulfur is plus 6. Okay. 16, 32. If charge of sulfur is plus 6, what does it mean? It means that sulfur has lost 6 electrons. So we need to deduct the 6 from its atomic number. 6 minus 6, 16 minus 6, it will become 10 electrons. In the same case, if sulfur oxidation number is, sulfur charge is, for example, minus 4. Here atomic number is 16 and 32. It means that minus 4, it have gained 4 electron. So 16 plus 4, minus means gaining of electron. 16 plus 4, number of electrons would become 20. So now sulfur has 20 electrons. Okay, because it has gained 4 electrons, so that's why its number of negative charge is increased by minus 4. So I hope that you have understood the concept related to the finding electron number of ions and atomic number, mass number.